Double displacement reaction. In a double displacement reaction, exchange of two different atoms or group of atoms or ions takes place. For example, solutions of barium chloride and sodium sulfate in water react to give insoluble barium sulfate and the solution of sodium chloride. Please refer to the word equation given in the slide. Barium chloride plus sodium sulfate gives barium sulfate plus sodium chloride. The insoluble substance formed is known as a precipitate. Any reaction that produces a precipitate can be called a precipitation reaction. The white precipitate of barium sulfate is formed by the reaction of sulfate ion and barium ion. The other product formed is sodium chloride, which remains in the solution. Thus, double displacement reactions involve an exchange of ions between the reactants. Another familiar example of precipitation reaction is the lime water test for carbon dioxide. Filtrate obtained when saturated aqueous suspension of calcium hydroxide is filtered is called lime water. Carbon dioxide reacts with lime water and forms a cloudy precipitate of calcium carbonate and water. Please write word equation for this reaction. Word equations for some double displacement reactions are given in this slide for your reference. 1. Reaction of barium hydroxide with ammonium chloride. 2. Reaction of barium chloride with aluminum sulfate. 3. Reaction of potassium bromide with barium iodide. The first reaction in this slide, which is reaction of barium hydroxide with ammonium chloride forming ammonium hydroxide and barium chloride, is an endothermic reaction. Endothermic reactions absorb energy. When the bottom of the test tube containing the reaction mixture of barium hydroxide and ammonium chloride is touched, it will be very cool. Another example of an important endothermic reaction is photosynthesis. In photosynthesis, plants use energy in sunlight to make glucose and oxygen from carbon dioxide and water in presence of chlorophyll. Please go through the general reaction pattern of the four major types of reactions, namely combination reaction, decomposition reaction, single displacement reaction, double displacement reaction. Oxidation and reduction. Reactions also involve the gain or loss of oxygen or hydrogen by substances. Oxidation is the gain of oxygen or loss of hydrogen. Reduction is a loss of oxygen or gain of hydrogen. Please look at the figure. A china dish containing small amount of copper powder is heated. The surface of copper powder becomes coated with black copper to oxide. Here, copper powder has undergone oxidation reaction. Can you write the word equation for this reaction? If hydrogen gas is passed over heated copper 2 oxide, the black coating on the surface turns brown as the reverse reaction takes place and copper is obtained. In this case, copper 2 oxide has undergone reduction. The word equation for the reaction is given below. Copper 2 oxide plus hydrogen gives water plus copper metal. During this reaction, copper 2 oxide is losing oxygen and is being reduced. The hydrogen is gaining oxygen and is being oxidized. In other words, one reactant gets oxidized while the other gets reduced during the reaction. Such reactions are called oxidation-reduction reactions or redox reactions. The two processes, oxidation and reduction, are symbiotic. That is, they must take place together. It is worth noting that all single displacement reactions are redox reactions also. Some more examples of redox reactions are given for your reference. 1. On heating, zinc oxide reacts with carbon to form zinc metal and carbon monoxide. 2. On heating, ferric oxide reacts with aluminum metal to form aluminum oxide and iron metal. Let us consider both the reactions given in slide 30. In the first reaction, carbon is oxidized to carbon monoxide and zinc oxide is reduced to zinc metal. While in the second reaction, aluminium metal is oxidized to aluminium oxide and ferric oxide is reduced to iron metal. In a redox reaction, the substance that helps in oxidation is called an oxidizing agent, while the substance that helps in reduction is called a reducing agent. In the reactions just discussed above, since zinc oxide helps carbon to undergo oxidation, it is an oxidizing agent, while carbon takes away oxygen and helps zinc oxide to undergo reduction. Therefore, it is a reducing agent. In the second reaction, ferric oxide is the oxidizing agent and aluminium is the reducing agent. Both corrosion and rancidity involve oxidation reaction. Corrosion. Iron articles which are shiny when new get coated with a reddish brown powder when left for some time in contact with air and moisture. This process is commonly known as rusting of iron. The black coating on silver and the green coating on copper are other examples of corrosion. Destruction of metals layer by layer in the presence of air and moisture is called corrosion. Corrosion causes damage to car bodies, bridges, iron railings, ships, and to all objects made of metals, especially those of iron. Corrosion of iron is a serious problem. Every year, an enormous amount of money is spent to replace damaged iron. Rancidity. Have you ever wondered why certain nuts taste bitter after few days of buying them? Similarly, the taste and odor of fat or oil containing food materials which are kept exposed to atmosphere for a long time also changes. This is due to rancidity. Rancidity is development of undesirable odor and flavor in the food items due to the breakdown of fat or oil present in the food item. Fats or oils, when left exposed to atmosphere for a long time, turn rancid due to oxidation. Rancidity can occur due to three reasons: contact of fat or oil in the food with air, moisture, or microbes. Keeping food in airtight containers helps to slow down oxidation. In order to increase the shelf life of the food items, usually substances which prevent oxidation, called antioxidants, are added to foods containing fats and oil. Have you ever wondered why the bag of potato chips appears to be inflated and seems to have more air than the amount of chips in it? Chips manufacturers usually flush bags of chips with a chemically non-reactive gas and not air, such as nitrogen, to prevent chips from getting oxidized. If the packets were filled with regular air, the chips would likely turn soggy and spoil. The nitrogen gas in the snack packet not only keeps the chips fresh, but it also protects chips inside the packets from getting crushed during handling and transportation. Module 1 gets over here. Some important topics or points discussed in this module are summarized in two slides, 33 and 34. Points incorporated in slide 33. Chemical changes involve chemical reactions. Chemical reactions basically involve changes to the arrangement of atoms and the molecular structure of materials. In a chemical reaction, no atoms are lost or made, but they are rearranged. A chemical change or a chemical reaction is said to have taken place if there is change in state, change in color, change in odor, evolution of a gas, change in temperature, formation of bubbles, formation of a precipitate. All chemical reactions can be represented using word equations. In a combination reaction, two or more substances combine to form a new single substance. Points incorporated in slide 34. Decomposition reactions are opposite to combination reactions. In a decomposition reaction, a single substance decomposes to give two or more substances. Reactions in which heat is given out along with the products are called exothermic reactions, while reactions in which energy is absorbed are known as endothermic reactions. When an element displaces another element from its compound, a single displacement reaction occurs. Two different atoms or group of atoms or ions are exchanged in double displacement reactions. Precipitation reactions produce insoluble salts. Oxidation is the gain of oxygen or loss of hydrogen. Reduction is the loss of oxygen or gain of hydrogen. Slide 35 consists of questions for practice.